Hello everyone. In celebration of reaching 20,000 subscribers, I thought I would make a new fun video. What I'm going to do is make a tier list of 50 common data visualization techniques. So basically, I'll be rating 50 different types of data visualizations, essentially based on their usefulness and how often you're going to find them useful. So let's get started. First, we've got the scatter plot. This is an easy S tier, might be the best plot of all. It's just super useful for looking at two numerical variables. You'll use this and see this all the time. So that's easy S tier. Now the bubble plot is very similar to a scatter plot, except the points are given area based on a third dimension. I think this is quite a bit less useful. The area is not super easy to make out a lot of times. So I'll put this at a B tier. And then we have a 3D scatter plot. We're basically adding another dimension to it. Now, this really depends on if the graph is interactive or not. If it's not, it's like an F tier. But assuming it is interactive, I'm going to put this also at a B tier. It can be a useful way to look at 3D information if you have that interactivity and can swivel it around. Next, we've got a histogram. This is another one that's going to come up all the time. It's a very useful way for looking at distributions. So I'm going to put that one at S tier. Now we've got a 2D histogram. So basically, you've got histograms on two different axes and then kind of what amounts to a density plot or a KDE in the middle. This plot is pretty useful. It's not quite as used as a normal histogram, so I'm going to put this in A tier because I do think it is useful. It's just not used quite as often as a standard histogram. Now I've got a 2D density plot. This is very similar. Basically, what you have in the middle of this 2D histogram is a 2D density plot, what amounts to that. So I'm going to put this at the A tier also. This is used quite a bit. It's basically a KDE plot. And again, heat map is very similar to this. The 2D density is just kind of a continuous curved version of a heat map, and you'll see heat maps all the time as well. So this is pretty useful. I'm going to put that at A tier as well. The hex plot is similar in principle to both of these. It's essentially a density plot, but instead of squares or continuous curves, it's hexagons. I'm going to put this one at a C tier just because you don't see these quite as often, and if you're going to use one, you kind of might as well use one that is used more often and has better guides for it and is just expected to be seen more. Next, we have a dot plot. This is basically like the histogram, except you have discrete points instead of bins. I think this is probably a bit underused and is actually pretty good, so I'm going to put this at an A tier. Many instances where you're using a histogram, you might actually be better served with a dot plot if you have small enough data that you can actually plot it all, because then instead of dealing with bins where you have to worry about where the dividing lines are, you can just actually see all of the points, which can be pretty nice in some cases. Now we have the density plot. This is similar to a histogram, except you're not going to have discrete bins. It's kind of a continuous curve. I'm going to put that up at S tier also. Two different ways of looking at a distribution. I think the histogram is a bit better, so I'm going to keep that one above, just because the density plot, the y-axis, it's not always clear exactly what that means because it's a density instead of a count, but it's something that's used a lot and is pretty useful. Now I'll do the 3D density plot. This is quite a bit less used and less useful. It's, again, if you don't have interactivity to rotate this, it's going to be pretty hard to tell where all the lumps are and stuff. So I'm going to put this one at a C tier, maybe above the hex plot though. But I just think it's hard to get a lot out of a 3D density plot unless you have really good interactivity. And even then, it's like two different people are going to rotate it in different ways and not get the same information out of it. So it's not ideal how it's conveying data. Next, we have this ridgeline plot. It's not actually one I've seen too much, but it's essentially a whole bunch of density plots broken down by some other factor, where you can see how the density changes based on that factor. This is actually pretty interesting, and I think it could be useful. Since it's not used that much, I think it can't really go above a C tier for me. So I'll put it there. Maybe the hex plot can go below it. It's kind of interesting, but I just don't see them all the time. Next we have the box plot. This is a pretty easy S tier for me also. It's used all the time. It's a very easy and quick way to graphically convey the median and interquartile range and some outliers. You can also break them out with side-by-side box plots. So it's just overall useful plot, seen all the time, and good at conveying the information it's supposed to convey. On the other hand, the violin plot it's basically like a box plot that's also trying to double as a density plot at the same time. I feel like the violin plot is just kind of too overloaded with data. Trying to add in the density aspect for me is just a little bit too much, and I'd prefer maybe box plots with some other plots along with it instead of trying to do everything in one. So I'm going to put the violin plot at a C tier. You do see these used, so maybe it's above some of these ones that are lesser used, but I personally just don't really like the density component of it. I just feel like it's usually hard to see exactly what that's telling you. Next we have the line plot. This is another S tier, used all the time, very useful, and basically anytime you're working with time series, you're going to have line plots with some kind of date or time on the x-axis. I think this actually deserves to be higher up in S tier also, probably right below the histogram maybe, because they're used all the time and they're very useful. So next we have a stacked area plot, basically a line plot, but it's breaking things down over time. I don't think these are quite so useful because it's hard to compare the sizes of the areas over time often. So it's not easy to get the information that you're kind of meant to get out of these all the time. So I'm going to put this at a C tier just because they are used a fair amount, but I don't think they're always a great way of conveying the information. I'm going to move it up to maybe the top of C tier just because you do see these with some frequency. Next we have the scatter plot matrix. I think this is an A tier plot. I'm going to move it up because you do see these a lot as well. Maybe move it to the top. So basically a scatter plot matrix is showing you kind of all the pairwise scatter plots of your data, of numeric data, and then on the diagonal you'll have density plots, and on the top triangle you'll have correlations. So it can be a pretty good way of summarizing some numeric variables really quickly and just kind of trying to figure out what their relationships are. But now we have this other correlation matrix plot. Now this is similar to the scatter plot matrix, but it has these little circles that are colored in shades of red and blue based on intensity. And I don't personally like this plot very much. You do see these all the time, and I just think that if they're not labeled with the actual correlation numbers, it's very hard to tell what the intensity and size of these circles really means. It's much better to have an actual number there. So I'm going to put this one at a B tier, even though they are used probably equally as much as the full scatterplot matrix. It's just harder to get the information out of them. So next you have the bar plot. This is basically the standard way of showing categorical data. So this is an easy S tier. I'll probably even put that above the histogram because basically scatterplot is maybe the best one for numeric data. At least you have two things to compare. Bar plots are probably the go-to for categorical data, so we'll put that up there. And the side-by-side bar plot, this is pretty good too. You're basically breaking down the bar plot by some other factor. I'm going to put this at A tier just because it being side by side, it's a little less used than the standard bar plot, but you will be seeing something like this very frequently. I'm going to put that pretty high up too because I do think it's pretty useful, and since the bars are side by side, there's no judgment calls in terms of which are taller, so it's pretty useful. So next we have the stacked bar plot. I don't like these very much. It's often hard to compare the different segments across the different bars, so it's difficult to see the information you want to see. They are used a fair bit, so that maybe bumps them above some of the lowest tiers, but I'm going to put it in C tier because I personally find it pretty hard to get the information you need to out of them. I'll move it up a bit though just because they're used so often. Next we have the column range chart. This is a kind of plot that's basically a bar plot, but it's showing you ranges of variables with bars. It's not used quite as often as some of the other bar charts we looked at, but it is better than the stacked bar plot in terms of actually being able to read the data. So I'm going to put it in C tier also, maybe above that one, just because I do think it shows the data better, but it's just not quite as often used. All right, next we've got the Radial Bar Plot, basically a bar plot but oriented in a circle. I'm going to put this at F tier. I don't see any reason you'd use this over a standard bar plot. It just makes it harder to read. And the circular bar plot is the same story. If you have data and you want to break it down by categories, there's no reason to do it in a circular orientation. You could just use the side-by-side bar plot or something else. So this is going to be another F tier for me. Next we have the pie chart. Now this is one that kind of data visualization hipsters like to hate on and say you should never use it. And, you know, maybe that's true in certain circles, but I think that it's one that essentially everyone knows what it is, and business people know what it is, and that in and of itself has some value. So I think the pie chart is actually fairly decent if you're going to limit the number of sections to just a few and put the actual percentages on the segments. If you do that, I think it's a C tier plot, probably at the top of C tier, just because everyone knows what it is and it can convey your information pretty quickly. But if you don't do those things and follow best practices, if you use too many segments or don't label things, then it drops pretty fast. But as long as you do things the right way, I think it's can be C tier. And the donut chart is basically the same thing, similar information. So I'm going to put that next to the pie chart because they are used very often. And the 3D pie chart, on the other hand, should never be used. That's low F tier. Basically, anytime you're trying to make something 3D, but the third dimension isn't actually coming from data dimension, it's just kind of visual 3D with no other reason than aesthetics, then that is immediate F tier for me, because that just adds complexity to the visualization without actually mapping any data to anything. It just makes it more confusing to read. All right, next we just have a standard map, essentially a map of roads. It could be any sort of map, just a map of physical locations. I'm going to put maps at S tier. I mean, we all use maps. They're super useful when they're warranted. There is the caveat of what you actually put on the map and how it's displayed can really affect how useful the map is. So used improperly, a map might not be very good, but it has great potential, and it's basically the best way of succinctly showing geospatial information. So I'm going to put that at S tier. I'll keep it at the bottom though, just because it's not going to be useful in every analysis. It's a kind of a case-by-case thing, whether a map is going to make any sense. But when it does make sense, you probably need one. So next we have a different sort of map, the Coropleth map. So this is also a very common sort of data visualization to see. I think it's actually pretty easy to misuse though. Like if you use a Coropleth but do things based on counts, you'll often have sections or polygonal regions, like states say, that have darker shading or a higher count of whatever the Coropleth is about, simply by virtue of its size. So like California has a lot of people, so if you make a Coropleth that's just shading based on population, well, California is going to be really darkly shaded because it has a lot of people, but that's partially just because California is so big. So it's a lot more interesting to use Coropleths to show ratios and per capita information, because then it's more of an apples to apples comparison that factors out the sizes of regions. So just for that fact, and they can be misleading, I'm going to put it in B tier, even though they are used pretty often. I might put it up a little bit just because I do think it's used more often than some of these other ones. All right, next we have the Hex Map. This is basically a simplified sort of map that breaks down regions that you might see in a Coropleth into same-sized hexagons. It's basically a super simplified way of, say, showing all the states and then coloring them in. These are actually used somewhat frequently, but I don't really like that they kind of lose the geographic information of the map. So for me, I'm going to put this one at a D tier, just because I feel like oftentimes when you use these, you could have just used a normal map that preserves the shape of what you're looking at. All right, next we have the tree map. This is basically a way of organizing and categorizing variables within different bins. I don't see tree maps used a whole lot and used effectively. The main thing I can think of that even uses something like this is there's like a hard disk scanner that groups all the files in your computer in some sort of tree map. But they're pretty hard to read, and they can get really cluttered if you have a lot of categories. So I'm going to put this one at a D tier just because I think it's kind of hard to get the information you're needing to get out of them. And I'm going to put Mosaic Plot in the same tier. It's a similar thing it's trying to do, break down different variables on different axes, and they're just pretty confusing to read, and there's usually a better way of showing the information, like some different bar plots or just perhaps tables of data. And in the same vein, the packed circles plot is kind of trying to group related things together with a whole bunch of circles instead of squares. Again, this is a plot that's pretty cluttered and kind of hard to see exactly what it's showing you, so I'm going to put that one in D tier. All right, next we have the QQ plot. These are often used in normality testing to kind of get a visual sense of whether data is aligning with a normal distribution. Although these are used quite a bit, I'm actually going to throw this in C tier toward the top because it's used quite a bit, but I actually find it's kind of difficult to tell on a normal QQ plot whether the data is actually normal or not. Like oftentimes I think, oh, that doesn't look normal because the tails are trailing off, and then you look at an actual test statistic and it's not aligning with what you think the plot is telling you. So it can show very obvious divergence from normality or whatever other distribution you're using one for, but I think it's just not a super strong visual indication of what it's trying to show. All right, next we have the Pareto chart. It's kind of a combination between a bar plot and a line plot that is rank ordered by the counts of the different categories. This can be useful when it's called for. It's just not a plot that's going to be seen all that often. So just by virtue of it not being used super often, I'm going to put it in the C tier, maybe around where the column range chart is. So next we have the Snakey Diagram. This is one that seems to be used often for fun to break down things like budgets or job application success and things like that. So as something that's more of a for fun than it's easy to get information out of it, I'm going to put the Snakey Diagram down at D tier. I don't think this is something you're going to be using a whole lot for kind of serious analysis and data visualization, but it is one that can be fun to look at. Next we have the Sunburst Plot. Again, this is one that kind of looks cool, but getting actual good information out of it is not so easy. So I'm going to put this one at the D tier, maybe above some of these other ones that are maybe even harder to use. After that, we have the tree diagram. Now this one is used quite a bit in predictive modeling because when you're making decision tree based models, you can create a tree diagram and visualize it to see kind of the decisions that are being made. So that can be a pretty useful thing to do. So I'm going to put it up at the B tier because I do think it can be valuable to inspect a tree diagram, but you're not always going to be making tree-based models, so it's not something you're going to necessarily use all the time. The Dendrogram is kind of similar to a tree diagram in that it has a tree-like structure, but where this is typically used is in hierarchical clustering to basically show where clusters are being joined, and it can help you figure out where to split the data to get the number of clusters that you want to get. Now I'm going to put this down in C tier. It is useful when it's called for, but hierarchical clustering is just not something that's necessarily used all that much. If you have pretty big data, I think hierarchical clustering has worse runtime complexity than something like k-means, which is pretty common. So that just limits the applicability of using one of these. Next is the parallel coordinates plot. This is one that you'll see with some regularity. I think that it's difficult to kind of follow the lines across these, especially if there's a lot of parallel coordinates. So I'm going to put it in C tier just because I do think you can get some decent information out of it, but it's just not super easy to follow. Maybe I'll put it up a little bit above some of these lesser used ones. Next we have the arc diagram, kind of showing relations between different things with connected lines across one axis. I'm going to put this one in D tier just because it's pretty hard to tell what the connections are. It can be just become a big jumble of lines. And on the same note, the chord diagram is pretty similar. It's showing connections between different things in a circular orientation instead of on a single axis. But it's very similar to the arc diagram in what it's trying to show. And again, it can end up kind of being just a big jumbled mess. Next, we have a network graph plot. And this might kind of seem similar to these two that I just put in D tier, but with a network graph, there's actually meaningful connections of some kind between all of the different nodes, and similar nodes will generally appear closer to each other and be interconnected, while other less similar things will be further away. Whereas in the chord and arc diagrams, the positions of things are just arbitrary and often arbitrarily spaced, whereas in the network graph, it can actually have meaning. So I think network graphs are kind of the best way of showing interconnectivity between nodes in a graph or network. So just because it's the best thing to use for visualization in that area, I'm going to put it in the A tier. So next we have the Venn diagram, basically just showing intersections between different sets. This can be pretty useful for thinking about set logic. Once you get bigger than maybe 3 sections though, or 3 overlapping circles, it can be really confusing to try to think about what the different sections are. So I'm going to put it in B tier. All right, here we have the Varroa Noi Diagram. And this is a lesser used plot perhaps, but basically what it's showing you is you have a bunch of points like a scatter plot, and then it breaks the area of the scatter plot down into sections where each polygon is the region that's the closest to any given point. It's kind of a way of clustering or breaking up areas based on the points in the area. I'm going to put this one in a C tier. It does have some actual data-based uses, but it's just not going to be all that common that you're going to need to use one of these, so I can't put it up too high. So next we have the radar chart. This one is kind of a way of showing different statistics for some entity. I think this one belongs in the D tier. It's something that's more just for fun and not actually useful in that many instances. And it can be a little bit misleading just because the sum total of statistics doesn't necessarily correspond to the area created by the radar chart. So you can have 2 different, say, characters you're mapping out statistics for, and they might have the same sum total of total stats, but the areas on the plot might not be the same. So next we have the word cloud. Similar to radar chart, this is more of a for fun type of data viz than it is something for doing serious analysis. So just based on that, I'm going to put it in the D tier. So for our next 2 plots here, these are actually more categories of plots than individual plots themselves. So this one is interactive plots. So basically visualizations that have an interactive component to them. I think that interactivity can actually add quite a bit to a data visualization, especially ones that involve a 3rd dimension or like a time dimension. So I'm going to put the concept of interactivity at A tier because I think it can really add a lot to a static plot in the right situation. Then we have animated plots. So basically a visualization that has a time component, like a video that you play essentially. I feel like animation in plots is often more for entertainment value than it is for actually conveying information effectively. So I'm going to put animated plots in the C tier. You do see these with some regularity. I have quite a few of them on my channel, but they're mostly for entertainment value and less for doing kind of hard analysis, but they can be an interesting way of kind of summarizing changes of things over time. Last, and also least, we have the tier list. Tier lists are essentially totally subjective, so they're not useful for conveying any sort of objective information for the most part. Hopefully they can be entertaining and provide maybe a general sense of how different things within the same domain can be roughly categorized or thought about in terms of usefulness or any other dimension you might want to categorize things by. But since they're ultimately driven by opinion and not by underlying data, I'm going to have to put it at the bottom of F tier. Hopefully in the case of this particular tier list, you found it at least somewhat useful in showing you the most commonly used and useful types of data visualizations and kind of touching on other ones that might be used somewhat but can be misleading. So thanks for watching, thanks to all these subscribers, and I'll see you next time.